This is question number 3, Pathfinder, kinematics, challenge your understanding. Starting from the center of a circular path of radius r, a particle P chases another particle Q that is moving with a constant speed, uniform speed v on the circular path. The chaser P moves with a constant speed u and always remains collinear with the center and the location of the chased Q. On which path will P eventually move and how long will it take to reach on this path? So this is first part. Second part, if the speeds the particles are given and radius is also given, how long P will take to reach Q? Let's solve the question. So it's a circle of radius r on which a particle q moves, and the initial position of q is denoted as qg. Q is moving with uniform speed v on the circle. There is a particle p at the center. Initial position is p0, and it's given in the question that p is always on the radial line joining the q. Suppose q is at this position after some time, q1, then p will be on this radial line. Suppose it's somewhere here. So this is the position of p corresponding to the position of q. So q1 and p1. So these are corresponding positions. Q will after some time move to new position. The radial line will acquire a new position, and p will be on this radial line at this instant. Suppose here. So this is p2 is the position of p corresponding to the position of q at that instant. That is q2. So this is how p is always on the radial line joining the q. The path of p in general a curved path, and since speed of p is given as u, its components will be suppose v double dash and v dash. V double dash is radial component and the other one is tangential component. These two components are the components of u, so therefore we can write u in terms of its components like this. Now suppose this position of p1 is at a distance of r from center. Notice that since P is always on the radial line joining Q, it means the angular velocity of P and that of Q, these two angular velocities are same, and therefore P is always on the radial line. It means P is turning by the same amount of which Q is turning. So equating the angular velocities of these points, angular velocity of Q is simply V over R. The angular velocity of P at P1 is the tangential velocity there, V dash, over the distance from center, that is r. So this is the relation equating the angular velocities. Now when p acquires a constant radius after some time, this v double dash will become 0, because what v double dash is doing, it is changing the radius. When radius is no more changing, then v double dash will be 0, and from here, if v double dash happens to be 0, u and v dash will be equal. So finally what will happen, v dash will become u, and if you put v dash as u, then r will become the final radius of particle p. So p will finally move on a circle and its radius will no more change. V double dash will become 0, and all its velocity will be in the tangential direction. So from here we can find the final radius. So it's equal to this expression, and you can very well see that if u is less than v, then this radius, final radius, is less than capital R. Okay. Now, if we write d by dt of r, which happens to be equal to v double dash, because v double dash is taking it outwards, then just cross multiply and put the value of v double dash as under root u square minus v dash square, and put the value of v dash as well. We have seen just now v dash from here, put the value of v dash from this expression. So putting the value of v dash, and then bringing all r terms on one side and times term on other side, and then integrate. When time is 0, r is 0, because particle is at center, and when time t, it is at its final radius. So we have to integrate this to get the time to reach to its final radius. You can verify these steps. So this is integrated, and so this is the value of final radius as we have just derived. and putting this value of r final in this expression and solving, we get equal to this. So this is the time when the particle starting from center will reach to its final radius. So this completes first part. The second part is what happens when u is more than v. When u happens to be more than v, then the final radius will be more than capital R. In that case, the particle P will cross the circle in which particle Q is moving. And since they are on the same radial lines, so when it reaches to the same radius, P and Q actually meet. So in the second part, we have been asked what is the meeting time. So meeting time occurs when the radius of P becomes equal to radius of Q. When their radii are equal, and since they are on the same radial lines, they will meet. So just put the value of r as r final as capital R here, because we have to find the meeting time now. And solving, we get the meeting time.